That's pretty good.
All right. Pretty good.
Yeah. Did you guys, anybody access those videos? Yeah. It's my first time doing this, so it's exceptionally weird for me to just sit there and watch myself teach. It's really weird. That's why I'm a real dork. But really humbling. That was funny. That was really stupid. No. Don't freak out.
You said you wouldn't surprise us.
So somebody was asking about the homework. What's sort of due today? Yeah. What's that? Oh, what's semi due today?
Chapter 1.
Chapter 1.
42.
So again, if you're not quite done with chapter 1 stuff, you've got time. But the further off you get from these little intermediate due dates, the more you realize you're getting further and further behind. Yeah.
Yes.
What's that? This year. One more of these. This guy.
Sure.
All right, guys. So last time we did section 2.1. I got a little bit of a preview, very tiny bit of a preview, section 2.2. Any questions left over from chapter 1 or the first part of 2?
Do we have an assignment for chapter 2 for 21?
You have an assignment for everything we're doing.
I didn't get this example.
Where's that?
So we've had it. 2 going to 1.
Oh,
It's
yeah.
not a matter.
Give me that
I didn't get it.
We'll do that one. All right, guys, so I got a question, page 94. There's example 7. And it's one with, oh, real quick, before I forget, this won't constrain, this is trigonometry, all this weirdness, but there's a fractions workshop, just in case anybody needs that. It's mostly for 90 and below. There's also a graph and calculator workshop. A graph and calculator is not required for this course, but in case you got one, or in case you're going to get one, because you might be going to statistics, like I said, you should get one now. If you want to go, there's 3 workshops this week and then 2 more next week. I'm doing 3 of them, 2 of them, and I got 2 of my tutors doing the other 3. Okay, so if you're curious, they're up there, and you should have gotten an email from me too. If you haven't checked your email in a while, make sure you're getting those emails from me.
Video? Video?
Yeah, I'm going to videotape the one I do, both of them, and then pick the better one. Put that up. Maybe I'll put it together.
She didn't receive
I
anything.
didn't receive anything from you.
Okay, so see me after. Okay. All right, so any other questions from chapter 1 or section 2.1?
Yeah, 2.1, page 101, number 90, please.
Let's see. Oh, so this is kind of nice. I almost forgot. The nice thing is Pat's question has a decimal in it. This is going to help us out.
What number is this?
This is number 90,
Number 90.
page
85?
101. This one here, right? Mm-hmm. Okay. So a couple things going on here. Looking beyond the fact there's a decimal in there. If it was x plus 6x, what would you do first?
Last second.
Yeah, you want to combine like
Combine it, yeah.
What is x plus 0.06x?
Every 1.06.
I love it. Not 0.07, right?
No.
Because 0.01x plus 0.06 would be 0.07.
One
A
point
whole x, you could put in front of it a 1.
Yes.
If you really feel like at $1 is 1.00, you can put as many O's as you want to after decimal, right?
Yeah.
So 1.00 plus 0.06 is 1.06. And now you're almost done, right? All you have to do now is what?
Divide by 506.
Yeah, exactly. You know? It's almost like I keep changing the numbers. I keep changing the players and the play, but the play didn't change. Whatever the hell's in front of the X, you divide by it. Just happens to be a decimal now. Thankfully, I don't make you do long division. You divide that, I think you should get 900.
Yeah, 8. 1.5.
891.5?
900.
Yeah, 900.
Oh, so we round everything off, right?
No, no, no. You should get 900. Yeah, so do it again in the calculator. 954 divided by 1.06.
Oh, okay.
Alright,
I,
cool.
I want.
How's that? Is that all right? Does it help out with decimals in general? Okay.
Yeah, I just thought that you took the X and added the X. Yeah.
No, because you don't have a whole X here. You have a whole X here, but you don't have a whole X. You got 0.06 X's. Yeah. There's not two whole X's in there.
So you one to that.
This is 1X, and this is only 0.06X. So how many total X's do you have? 1.06X.
But like that other problem, it had a lot of those, like 0.05 and then.
Oh yeah. So here's an example I think that'll answer the other question with decimals. What if I had this disgusting looking thing here? I don't know. Let's make this, sorry. Yeah. If you wanted to, what is a decimal anyway? I mean,
It's tenths.
it's certain tenths or hundreds or thousands, right? It's pieces of numbers. It's fractions. They're just fractions. They're fractions that happen to have our number system's base in it. What the hell does that mean? I mean, what base do we have for our number system? And why do you think we have that base for our number system? We have 10 freaking fingers. And how do we start counting? We do 1, 2, 3, 4, 5, 6, 7, right? In fact, there's tribes where they start counting from this foot up and then down, and the names of the numbers correspond to the names of those body parts they're on as they count up and over. That's really freaking neat, right? So if we had 8 fingers, we didn't have any pinky. We need our thumbs, or else we don't evolve. We need it, if we didn't have our pinkies, we'd have a base 8 number system. We go 1, 2, 3, 4, 5, 6, 7, 10, 11. Freakiness. You don't have to worry about that on the test? No. So don't worry. I just want to show you neat things about our number system. So these are just fractions. If I had fractions in an equation, how could I get rid of them?
Times that by 100.
Multiply by the denominator. And all of these are over 100, aren't they? 4 hundredths to it. So just multiply everything by 100 if you want to kill the decimal. Do you have to? No. If you don't worry about decimals, you can let them live. So here we get 4x because it moves over once, twice.
Minus 2
Good.
equals 33 times x minus.
Now, do you multiply the 100 in there also?
No.
You only have 100. Once it multiplies by this, there's no other 100 to go in there, right? It's another place where people kind of mess up on that kind of problem. That's the same, 3x minus 3. Now that looks pretty straightforward, right?
Isn't that the one?
It will be,
Okay.
once you multiply that through, right?
Yeah.
Cool. So then you have 4x minus 2.
3x minus 1.
And that kicks so much butt, because now if you subtract 3x, add 2, negative 7.
Okay.
Cool.
I made it harder.
But it's easy to do that. I mean, overthinking happens a lot. And we all know that. We all overthink things. And it really sucks when you get a test back and you're like, it was easier. Damn. That's why I always say assume it's easy until it proves itself hard. Don't assume it's hard right off the bat. Yeah.
Number 102. 2.1.
All right, so something about coughs and earaches. Twice as many people visited their doctor because of a cough, that one?
Yeah.
Okay, blah, 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 blah. So this is kind of getting us ready for what's coming up very soon, what we're going to get into today, which is everybody's most favorite part of algebra,
Application.
otherwise known as word problems. Oh, yeah, that's like the euphemism for it, the easier, the nice, politically correct, right, applications, so they're word problems, right? We're getting into that today. This is getting us ready for that. If x is the number of earaches, what must be the number of coughers? Number number of coughs just sounds weird, but we'll just go with it.
Just twice?
If the number of earaches is X, the number of coughs must be twice that, like they said, so it has to be 2X. Or just 2X, you don't really need a parenthesis. So something I really want you guys to get down now is the big part of word problems. The most important step in a word problem is identify what is just X, right? Then everything else comes off of that. Like if they said, Fred makes some money, Bob makes 7,000 more than Fred. Well, if Fred is X, then Bob is X plus 7,000. Everything builds off of each other. You don't call it X and Y, not yet. Don't bring in more variables until we have to, right? So the number of coughs must be twice the number of earaches. That's what they told me. Cool. And then they tell you, blah, blah, blah. Write an equation that relates 45 million to the variable X. But personally, what I would do is I don't like all those zeros.
45.
Just put 45 and then we know it's in millions, right? You don't write all those stupid zeros. So what would the equation be if there were 45 million total earache and cough people?
2x equals 45.
Careful, 2x plus x, right?
Equals 45.
Cough people, earache people. When you add them together, you got to get 45. And we understand it's in millions. Is that right?
3X?
Yeah, and then you can solve it. Now it's an easy equation to solve. 3x is 45. So x is 15 million. 15 million who? 15 million earache. Cool. So if you tell yourself what the hell is going on, it's easier when at the end you say, okay, you got X, that's great. What the hell is it? 15 million cases of earache. So then how many coughers? Twice that, 30, and thank God they added to be 45 million, which is what they're supposed to add it to be, right? So 2x is 30 million, and that's the coughers. Adds with the 45 million, that's a good check, right? Thank God I got all my people. Didn't lose anybody in the hospital, yeah.
Page 94, exercise 98.
84.
94, 84, 84.
Number 98?
Yes.
Oh yeah, that's my favorite one.
Oh, good.
Yeah.
So it's good, right?
I don't know, yeah, it's probably not a good thing to hear your math teacher say.
It's my favorite one.
This one's freaky. Because you got one in that's like 1, 2, 4, and you know, like you add 1, you add 2, you add 3, you add 4. That one you can get pretty quickly. This one might take you forever if you've never heard of it, or if it just doesn't come to you. Anybody know what that's called? That sequence. It's actually given a full name. Named after the guy that came up with it. Who knows? It looks like somebody knows.
Like you add the number before it, like 1.
So 1 plus 1 is 2.
Yeah.
1 plus 2 is 3.
3. 2 plus 3.
2 plus 3 is 5.
3 plus 5.
So 3 plus 5 is 8.
Yeah.
So that's the answer.
That's the answer, huh?
And you can keep going forever until you go crazy. The really cool thing about that is, if you think about taking a 120, there's a lot of different teachers teach a lot of different things. I always make sure I teach this, because you can actually have a whole year's worth of a class about this. This has to deal with, if you take numbers out of the sequence and make harmonies out of them, like frequencies that are in the sequence. Any musicians out there? Anybody a musician? Yeah? Hit the tuning fork, you got the 440, you got all that kind of stuff. If you take numbers that are in the sequence, it creates sounds that we as humans like. If you take numbers that are not in the sequence, it makes sounds that wake us up in the morning. It's weird. If you make, there's certain dimensions, like the pyramids of Giza, they have this, what's called the golden ratio.